Whichever measuring system you're using, once you do your indium and your zinc and you do your furnace calibration, everything will be referenced to that thermocouple on the side, and the calibration software will bring them together. You get a good solid calibration that way. If you're putting your thermocouple close to your sample, not so much. You really don't know where you're going to be, and it's hard to reproduce it. So we've gone ahead and put this together. We have our thermocouple here, and we're going to put our probe on. Now we have this core rod. It's about that long. As a matter of fact, I probably need to get a picture of one for the next one. It's important that it's straight. And when you put the probe on, you need to remember that core rod is stainless steel. This is stainless steel. You do not need to crank them down like a gorilla. We've had folks come in here that really turn these things tight, and the only thing you can do is you're not going to get a better connection past anything other than a real tweak. But you can physically twist the core rod, and you can physically twist this, and you're no longer straight, which can be really problematic. So our instrument's off. We've got our core rod right here. We've got this all together. If this does not come down straight, we can always take it off. Take a put an Allen wrench through here to hold it stable, and loosen this slightly and maybe tweak it. So when you're all set up, if this comes off 45-degree angle and it's bad, then just simply tweak this and move it 45 and then put it right back on and try it again. So I'm going to go ahead and put this in here for you. We're going to put this down into the furnace. And we're going to come down here. This has the larger wedge on it here. It just happens to be the one that we got. It does not, it could be any one of them. A smaller one, it could be a bubble, depending upon your running. We're going to put this down in here, and we're going to come up. Okay? Now, right here, there's a pin coming in between here for that core rod. So it's the only thing that's really holding us in here. So we're not going to twist this very much. We're going to put an Allen wrench through these holes up here, and we're going to, we can do this, but it really doesn't need to. Just a little tweak like that. You'll be able to feel it as much as anything. It's, again, it's stainless steel, very fine threads. When you turn it down there, it does not take very much force to make it solid. The next thing we're going to do is we're going to come up here. We're going to put this pin towards the front, if you can see it, and we're going to lift this all the way up in there and start turning this knob. And then you'll see it, you may not see it on this film, there is a receiver for your thermocouple right here. And we'll keep this up in the air, the extra thermocouple wire, so that you can easily close this without pinching it. You start pinching these, if you're not running corrosives, they last a long time. You start pinching them, you can start breaking them a little bit. So try to make it so it's kind of easy. We leave this up so in case you want to check the, looser, in case you want to ever check the bubble to make sure you're there. We put it back together. And now, we've got a computer wired up, we got our plumbing back there, we've got our analyzer, we've got our furnace here. By the way, there is if you want to run liquid samples, run anything within a liquid, we do have inserts that we make that'll go down here inside the furnace. So we can, if you were going to do it that way, that would be here at that time. And we're ready to turn it on. Now what we're going to do when we turn it on, we're going to turn the analyzer on first. We're going to turn, we're going to turn the computer on first. And right now this is sitting on that one, but the computer we're using is actually this one. We're going to turn the computer on first, and then we're going to turn on the analyzer. It really doesn't matter a lot in what order you'll do this. When you turn on the analyzer, the probe should pop up, oh, what is that, a couple millimeters probably. You'll see where the motor is keeping this probe right now. If it's a little bit of angle, you can always turn this, or you can adjust the sample platform to what an angle so you don't have to take it all apart. Or if you want to keep the sample platform in a particular place, you can take the probe off and adjust the head like I told you a little bit earlier. So this is sitting here, computer is up, this is on. The next thing we do is we turn on the tach. This and the order of these two are not that important, but what is critical is that this is the last thing. So we turn on the tach, all the lights pop on, comes up with ready. It can also come up with ready and the control light on if the, depending upon the temperature of the room and where the thermocouple is. And at this point in time, if you wanted to tell it to go up, it would go up. If you're, now there's one critical thing you have to remember right now. This instrument is not ready to go. What needs to happen on this, you need to open up your Pyro software, and the very early versions of these analyzers had two EEPROMs in there. You can identify them because they're 8005, 8006. PerkinElmer really wanted to make sure that it was as rock solid as they could, so they went to 8007, 8008. So this is not warming up. You remember the LVDT power supply I showed you right here? Well, that right now is at room temperature. What you need to have is that these analyzers go places where they have labs that are cold, they go places they got labs that are warm. Those two cartridge heaters are going to keep the LVDT power supply at 45 degrees centigrade. And that takes at least 45 minutes to really to equilibrate like it should be. So that 45 minutes does not start until you go here and you turn on the software, and the software takes control. Once the software is in control, the software is constantly monitoring it. Your heated zones become active, and the software is constantly monitoring all the safety features. So if something went wrong, it would immediately shut off all the heated zones. And we are coming up right now. Okay? And when you come up, you'll see, and we're going to go over this in the next video too, what you're going to see is you're going to see what the sample temperature is. You can see the default forces applied. You can see the block temperature. That's one of your safeties. So that's this temperature, and there's also a thermocouple on the block. And at this moment in time, we're ready to go.